considering shutting the Minneapolis, the Hennepin County Energy Recycling Energy Recovery Center down for a while now. The Minneapolis City Council just this past week finally voted to shut down the Minneapolis HERC, which is basically a garbage incinerator that generates enough electricity for 250,000 houses. It's 250,000 homes. Plus, on top of that, over half of the electricity for all of the skyscrapers in downtown Minneapolis. Now, our own scientists in the state, our own energy managers tell us that the air pollution generated from this incineration is so clean that the results on public health are so negligible. It's less than 0.01% of all cancer deaths in the state. And that if they were to shut it down, given the lack of other alternatives for trash, they would have to ship all of that trash that is now incinerated, providing energy for the state and jobs for the community, out of the metro area to a landfill. And that the fuel, the diesel fuel that those large garbage trucks would consume, would generate orders of magnitude more air pollution than the current air pollution being released by the clean energy burning incinerators that we've got now, comparatively so. And so here we have the environmentalists that have been advocating on an emotional basis for decades
I made it in.
to close down the HERC, and they finally got their
I
way.
had to set up my meetup account. It was just a walk through a field of
I'm sorry,
broken glass.
I'm almost finished here. And this is now the environment will lose as a result, and cancer deaths as a result of the increased air pollution will be triple or quadruple the number that it currently is. So I really view this as a form of eco-terrorism. They have further destroyed the planet, and now the blood of innocent murdered Americans will
Can
be on
everybody
their
hear me?
We can hear you,
So
Lionel.
this is
Can you
what happens
talk to me? Because I can't hear you.
this is what happens when we place feelings above facts. Facts don't care about feelings, and the numbers and the math don't change because of
No.
because of misguided emotional based thinking when it comes to the,
Jason,
and this is borne out by the mathematics. You could look this
Jason,
up. It's publicly available information.
Jason, this is a discussion that could take all day. You've simplified things simpler than was useful for the discussion if you were really going to discuss this.
I'm just bringing this to the group's attention that
Yeah, right.
energy,
You
ener-
told one side of the story.
energy sources are not simple and straightforward. We need these types of charts because the types of fossil fuels or the types of eco fuels and energy sources are not always simple and straightforward in terms of what we should or should not utilize. And this is a great example of emotions trumping facts and logic. And that's why we need these types of charts to make the numbers more clear.
I agree, but not with the rest of your description.
Well, I mean, innocent Minnesotans will die. We're talking about children.
First of all, that the city of Minneapolis council voted to shut down the Hennepin County garbage burner early.
And as a result,
but the Hennepin County has to vote to shut it down. The city doesn't have any control over that. And Hennepin County has said that before they're willing to shut the garbage burner down, the city of Minneapolis has to figure out how to deal with the city of Minneapolis's trash that's coming to the garbage burner.
They don't
That's
have
about 2/3 of the trash that's being burned every month.
We're going to have to truck it outside the city if we don't
or
burn
recycle it or mitigate it before it comes to the garbage burner.
Put it, gasify it. Come in today, throw it in the gasifier.
Yeah, the gasifier is what the city council voted to shut down.
Oh, well, that was really stupid.
Yeah, well, that's what Jason's saying. But
Okay.
there is a short form discussion that includes more facts than what Jason gave us.
Yes. Well, I have some of those facts, not for this meeting, but for a side talk.
Right. And that's what I was suggesting, is this would be a good side discussion.
Yes.
My argument, though, is that the increased carbon pollution will further worsen the environment.
Completely I understand what you're saying.
And increase the amount of cancer deaths in the state. So that is tantamount to murder and ecological suicide.
You're being really extremist.
You're using emotionally loaded terms that actually argue against or
emotionally loaded rhetoric.
Emotionally loaded rhetoric for persuasion sometimes works, but mostly doesn't with this group.
But it's the emotionally based rhetoric that I'm fighting against in the first place, which is kind of ironic.
That's like, yeah, exactly. That's like saying we need to kill to prevent killing.
David, do you have your participants list up? Because it shows you who's next.
At this point, I don't see any hands up.
Right. Oh, yeah, it just went down. There we go. It makes it easier for you to pick.
David, would it make sense to take that stuff from Minneapolis out to the RDF plant at Newport and run it through their processing, and then it eventually goes down to Red Wing or Mankato?
Where is Newport? Is that?
It's in the southeast corner of the 494 loop. It's it's
not in Hennepin County?
No, it's not.
That is the first challenge, I'm guessing, for Hennepin County is, can they truck it out of the county? Or do they need to pre-process it in the county?
Yeah, that plant's been doing, it's been around, even when I was working there, I used to buy equipment for them, and it's been there a long time, and takes care of Ramsey and Washington, and I can't remember which other county, and they have a pretty interesting system. They have even composting of food, and people put it in like a green bag,
right?
And when it comes in, robots pick out all the green bags and collect them, and it's pretty sophisticated compared to some of the other plants.
Mm-hmm. Well, if they have a gasification, they can make money from the operation out of the city and out of other regions and do it on a daily basis. So maybe the pathway is just to show them, hey, here's the income loss, and you're taking this out of our taxpayers' pockets instead. Why don't you go get it from the operation? And you're right on the railroad line, so go outstate, go anywhere you need to get it, and raise the income. So that'd be my approach to it.
Well, that's the argument that's been used for recycling for years. And unfortunately, with plastics, most of it doesn't get recycled.
Well, anything that has carbon in it should be in its own container, HDPE bottles and all of that, because it all has carbon in it, and they should sort it out at the curb. You put anything with carbon in it in the green bucket, and we'll weigh it when you get in, and maybe it'll be a part of your reward or something like that. And tree trimmings, all of that stuff. It belongs at the curb in the green recycling bins. That's my philosophy.
Would you distinguish between hydrocarbons and carbohydrates?
If it has carbon in it, I would not. Because all it does is it confuses the world. If a person gets used to, oh, if I have a bag.
Carbohydrates are food.
Right.
Yeah.
Yeah.
And I wouldn't separate it because it just adds to the cost. And
but carbohydrates can be composted where
Right.
many of the other carbon containing components like plastics don't do as well.
Yep, well, I'm just for a solution that brings money in, a parochial thing like Hennepin County's looking for composting. That just adds delay in, and so that slows the whole system down. You can gasify the compost, but and mostly outstate. They're not, people outstate aren't gonna get the carbohydrates separated out unless they adopt the program. But you can separate them for sure, other than it takes transit time and it takes up space.
A friend of mine is working on a bill at the legislature, and he got it partway through last year, and he thinks it'll go this year for recycling of a lot of different products. And they've calculated it out, and it looks like it's easily $1 billion industry that we could have here in Minnesota if we do it properly.
And you can also take the equipment and grind it up, and the sand falls out the bottom, and your rare earth elements and all of your metals and stuff are in that broken down stuff. So you grind it up, burn it one last time, and then send it into the metal processing, get the lead and get the earth metals from the chips and all of that. And that is a big industry. Again, adding probably billions. I think there's a letter to the editor that probably should be written explaining, unless they're in cahoots with one another, the city and the paper, but or put it on a referendum on the ballot.
Am I the only one who's noticed that Minneapolis used to have 4 daily newspapers with 4 different editorial boards and 4 different sets of opinions? And that's since I moved here, which was 40 years ago. St. Paul now has 1 paper instead of 3. It's a mono voice.
And are they on both sides of the spectrum, or are they polarized?
They were always polarized. It's just that you had 7 different polarizations to choose from.
Uh-huh.
Well, that's been the trend for everything. I mean, the idea of merging or reducing the competition and giving people less options for diversity in the economy and competing on price, that kind of thing.
Mm-hmm.
I seem to recall that before the St. Paul Dispatch merged with the Pioneer Press, that at least one of those publications was more conservative than the Minneapolis Star and Sickle, or this is Star and Tribune. So, some people have given it that nickname. But I've noticed in recent years that both newspapers are quite liberal and seem to agree with one another overwhelmingly on broad-based social, political, and policy issues. We really don't have a primary newspaper in the state that is conservative, libertarian, or otherwise. But this is not so surprising when most of the readership of the newspaper, the core demographic, has died out. The people that used to subscribe to these papers are all in the graveyard, and dead
Hey,
people.
I'm
Dead,
not.
dead people don't. Cross your fingers there. You know, you're whistling across. You're whistling across the graveyard, as they say. we, um,
I
the,
intend to be here for many, many more.
Yep.
a lot of people have said that. A lot of people have thought that.
And most of them haven't made it.
Yeah, the people that people in the cemetery generally don't pay for newspaper subscriptions, and the papers
But
that
they
are
do
left
vote.
are, yes,
Especially in Illinois.
some cases they do vote, sadly, but the papers that are still around are much thinner than they used to be. The quality of the journalism has gone down. You could even see basic spelling mistakes, very sloppy journalism, very little fact checking, and in my mind, the paper isn't the value that it once was. And these Star Tribune actually went bankrupt back in, I want to say, 2009. It's actually owned by a sports team owner currently. I think the Minnesota Timberwolves owner owns the Star Tribune, but we do not have neither the quality nor the types of broad dissenting opinions that we used to have in the state through consolidation. It's all the editorial boards of both primary papers are overwhelmingly liberal, and so there are no good conservative or libertarian or otherwise newspapers. One newspaper that gets really overlooked is the Epoch Times, started by the Uyghurs in China, and they do some really outstanding investigative journalism and really dig through and uncover facts that often aren't reported in the mainstream media.
So Jason, why don't you go to the task, put yourself to the task of creating a conservative online place where people can go? That's
Well, I don't have
There's
to.
plenty of conservative online places. He's talking about the print media.
I'm talking about print media. We're talking about newspapers.
He's dead. I mean, we know that, but everybody's getting their news online. So set up an online conservative website. I'd contribute.
I think the best sources of new media are impartial, and there are a number of third-party websites, kind of like Consumer Reports, that actually show all of the media websites, and it shows to what political spectrum they lean towards and how biased or unbiased they are. And so these digital media sources will actually comb through all of the mainstream media sources and give them a rating and show you where they fall on the spectrum. And I find that to be much more revealing and useful rather
It
than
throws an extra layer of something somebody has to do, and you'll lose half of your audience if you throw an impediment in there. You know, you got to go straight for it, or you won't have an impact. That's my opinion.
If you are talking about the Star Tribune, you may have noticed, if you're a subscriber, that it has changed recently. The format, the font and all that has changed, but also the editorials. I think they are pretty balanced now. For example, they don't endorse candidates anymore. They'll give both sides of both candidates an opportunity to write a commentary, and they'll be pretty non-judgmental about it.
how can you say that with a straight face?
Because it's happened. You can look at the paper in about 1 or 2 months ago. It changed.
Go look at the evidence rather than speculating.
Yeah, if you don't subscribe, maybe you don't know. It's to you, it's a rumor.
No, I actually do read the Star Tribune on a semi-regular basis. I've seen their modern work.
Tom, I just want to ask Tom Walsh, did you catch my emails regarding this presentation?
No, actually, I haven't.
Well, I could,
Get back in there.
I'm actually recording, and I'm also, I can present, but I thought if you wouldn't mind presenting, that would kind of make it a little bit faster, I think, to do the transitions. I actually sent you 2 emails. One of them has a doc file with all my videos, and the other one has just got the videos in the email, whichever way works best for you.
When did you send that?
About 10-ish last night.
I don't have it in either of my email boxes.
Oh, gee.
It's all right. I'll do it myself.
So are we Zoom Pro or are we Zoom the next level up?
Pro.
Pro, okay. And the next level up, is that the $60 a year, or what is it? I can't remember.
No, this level is 120 a year or 150 a year.
Okay, so it's the next level up.
The next level up doesn't buy us much except an expansion of the number of people from 100 to 1,000 per meeting.
And I think you get to download your videos, so you could put them somewhere without their.
Get that at the pro level.
We can do that now.
Oh, you can, okay.
I've not seen 100 people in attendance since my association began with this group over a decade ago.
And you probably won't.
Yeah. Can we just do a blanket email out to everybody who's on the list from time immemorial, and catch people who just have forgotten about it?
We don't have emails for even all of the people who are on this particular meeting. And in fact, there are a couple of people, I think, who are new. Would the new people like to introduce themselves? Most of us are regulars and are pretty well known to the group, but I see 2 or 3 names that I don't recognize.
Mm-hmm.
That sounds like a great idea.
Just briefly, for 1 or 2 sentences, why you're here, what your interests are. Hagen, would you like to start?
Yeah, sure. So my name is Hagen. I live in Rochester, and I'm a college student, and I work seasonal jobs. I formerly was in an engineering program, and I'm in a computer science program now. So I'm interested in anything related to the energy sector and technology, really.
Okay.
Do you have friends you could invite if you were given something to email out?
Probably not that would be interested in the same topics, but I could see.
Yeah, we doing a kind of a generic, today's today, tomorrow's the future. Where do you want to live?
Lionel, you want to raise your hand before you jump in?
Oh, I'm sorry.
Okay, see, we also have R.R. Tiki and Raymond. If you want to introduce yourselves, that would be nice.
R.R. Tiki looks familiar, but not sure.
Well, Raymond just muted himself, so
Um,
He just got his audio online too, so.
Raymond, you need to,
well,
Unmute yourself.
if he wants to speak, yeah. Otherwise, it is past time to start the
Yeah.
presentation. So,
Can I?
Tom, Tom's right.
yeah,
I
go ahead, Tom.
Okay.
I have participated in a Zoom call that had, we believe, 784 participants. This was mostly renowned because we had people from all 7 continents
Oh my goodness.
in attendance. It was a worldwide thing for the Mankind Project. It was,
You had somebody attending from Antarctica?
yep.
Wow. Okay.
The
Is there latency?
the model breaks down. Let me put it that way. Imagine each of the screens you have here having 100 people in it. It lasted for about an hour. Some people from the upper management gave a presentation and we all went away. It was a CF too.
Was there latency, Tom, for the distance latency?
There were all sorts of latency problems from everywhere. There were translation problems. There were television and video standard problems. There were.
Well, I don't think we'll have that problem today.
Yeah, no.
So,
But it can be done and it does work. Actually, it worked better than I thought it would, but we'll be happy if we can get up to 100 and keep it there.
I would think that everybody presented on the screen would be a couple of pixels would be just all they would see.
Yeah.
Yeah. Let's get to the presentation,
Yeah.
please.
Presentation.
Okay, well, I've got it ready. The first video we're going to see is a description of what Sankey diagrams are and how they started, or what this particular energy version of Sankey diagrams started. And I'm pretty much, I got it all set up, so I'm just going to go ahead and get it ready.
Dan, I can call on people, but at what point would you like to do Q&A?
I would say anytime after, not during videos, but anytime between videos would be fine.
Okay. And you're also recording?
Yeah.
That represents how many energy slaves we each use. And the other places I've heard that described as something like the equivalent of 600 times as much energy as one person can put out in a year. An interesting way of looking at it.
Okay, Chris, go ahead.
I found it interesting and that the majority of waste energy came from electricity use. Why would that be? Is it loss in transmission? Is it loss in generation? And if that is the case, then that is a problem, I think. Can anyone offer me an explanation for that? It was an interesting observation.
I'm next, and I can try to answer that as well as ask my own question. I think a lot of it is just due to inefficiency. When you burn gas, for example, a lot of that, as he said, is not used to drive the wheels, but it gets radiated away as waste heat and exhaust. So there's basic inefficiencies in the system, and that's where most of that comes from.
Does that mean that driving an electric car has a higher carbon footprint than driving a gasoline powered car?
No, it doesn't. But it depends, of course, on where the electricity comes from.
Exactly.
Um,
And since the electricity has a high proportion of waste, then it may be possible that that is not a good carbon footprint.
I think electricity transmission and use are more efficient than using fossil fuels. The generation of the electricity, if it's based on fossil fuels, that part would not be more efficient.
Exactly.
But it would be the equal inefficiency as using fossil fuels and burning them. So there are different phases of the process. There's the production, transmission, if needed, use. So they all have their different efficiency ratings.
That's
My
going to be covered in the next video, that process.
My question is, this video is 9 years old. I imagine if we saw a current flow chart, it would look pretty different.
Not
Do you have
enough.
any more current information on the proportion of the use of the different forms of energy, Stan?
Yeah, the next video is going to be more recent. I think it's up to 2022.
Okay. Carrie.
Yeah, I was just going to say that, regarding efficiency, for something like solar panels, there's the effort to produce the panel, but if the panel is 30% efficient, it's not really doing anything when it's just sitting there. So it's less of an impact than the additional gasoline you need to burn to compensate for all the heat, right? Because it's a limited resource, ostensibly, whereas the sun, if the panel's inefficient, you build more panels, there's a cost there, but it's not really doing anything once they're produced. You just need to have it sized appropriately. I would like to see an animation of one of these charts, from the earliest time we have good records for forward, so you can kind of visually watch as things shifted. I mean, that could be pretty entertaining, especially if you included things like, steam and wind power and whatnot for, transportation, moving over to coal, to diesel and whatnot. And then do we have a source for a good source for these charts where we could look at a historical version? I'd love to see a link for that. Anyway, thanks.
The link
all these videos that I'm showing are in the actual meetup, I think.
But the link is the Lawrence Livermore lab, I believe. National Renewable Energy Lab.
Okay. Tom?
Part of the waste is just unconscious waste. sitting here, I can see there's the light is on in the downstairs bathroom. The light is on the stairway to the basement. Nobody's going down to the basement. And if I go up the stairs, there's the kitchen where there's a coffee pot that's keeping 3 quarts of water hot
You drink a
so
lot of
that it can
coffee.
make we do drink a lot of coffee in our house. But it's just a feature of the coffee pot that it does this. And the I don't think I turned off the lights in the garage last night. It's just it's not unconscious waste, it's unconscious use to no effect. Marty's still asleep, but I'm sure all 3 of the computers on her desk are running.
Now, have you switched from your lights to LEDs, Tom? Have you switched to LED lights?
As the old ones burn out, we're changing to LEDs.
Yeah. That can make
That's
a
an
difference.
LED, that's an LED. The one in the basement stair was a hassle to change, and I think that's still it's some kind of a high efficiency fluorescent, which seems to last forever. It's still on. We have a very, very early compact fluorescent in a lamp in the room down there, and I can just see that it's still on. It has been running for 20 years. It only burns like like 5 watts.
I remember going into a Batteries Plus once, and they had 3 bulbs in a display with the amount of power they were using. The incandescent was, of course, the most serious problem, but the difference between fluorescent and LED weren't that significant.
No, but it just, a lot of it is just unconscious use.
But I don't think that's the waste energy that Lawrence Livermore has measured.
Well, I think that's part of it. I've read their reports. They talk about things like that. This is not new idea to me. This is their idea.
I see.
It's called phantom loads.
Unconscious use, where it's working but doesn't have to do anything.
I have a lot of gear in my rooms, like my studio for music and so forth, where there's a little LED on there. I have my printer over here. I see an LED on that.
Dan, your hand's not up.
Yeah, well, I am the presenter, but that's okay.
Oh, okay. I was sorry. I was thinking it was David.
Go ahead, Dave.
Yeah, I was gonna put a number on the transmission losses for electricity. The utilities typically say that it's lower than 10 to 12%. The production losses typically are something like 65 to 80% in a fossil fuel burning electricity production operation. Can be a little better if it's a steam turbine. They don't use piston generation anymore.
Also better if it's DC powered line.
Okay, Kerry, you're next.
Or very high voltage.
Yep.
That reminds me of the arguments between Edison and Tesla on that front. I was just going to say really quickly on the efficiency front, at some point we said, or somebody should bring up Jevons paradox. I think that's kind of an interesting how that factors into this. And this is the idea that as we get greater and greater efficiency, the costs come down, and then it actually encourages more, equal, if not greater usage in total, which is you keep running on the treadmill faster and it keeps speeding up.
Yeah, my hand's not up, but I'd like to add to that. It's similar to the effect of city planners run into this, building more highways. If you add 1 lane each way to a highway, the congestion gets worse because more people use it.
That's how, to me, it's like Hoover Dam was built and then Las Vegas was built. And then they got the biggest waste of energy going on the planet there with all those casinos and all the lights and stuff.
Okay, I think that's all the questions right now, Stan.
All right, so this is the next video, and I'm going to stop the recording. Jason.
Okay, Stan, anything?
Well, I think that the idea that I think Elon Musk a couple of years ago, when he did a major presentation on his innovations and so forth, said something to the effect that we only need to replace about half of the existing power consumption once we get transitioned over to renewable. And that I think that if you look at the amount of waste on the fossil end of the thing, that 30 to 40% of what we need to replace is that's much more doable. They said it so well in that video.
Okay, for comments, questions, let's try to keep it brief. Go ahead, Jason.
Anytime you produce energy, anytime the production of energy is done far away from the point of consumption, usually the case, physics will show that through the transmission lines and you're always going to have some amount of net loss or energy inefficiency that's through basic drop off. That's true of high power transmission lines for renewables as well as fossil fuels. Some enterprising companies like Bitcoin mining which are highly energy intensive and location independent, have set up Bitcoin servers at the point of this wasted energy to harness the free wasted energy to drive these Bitcoin mining operations. It's one use, but in order to harvest this wasted energy, you'd have to move people from where they're currently living to the points of production to utilize some of this energy. That's not practical either, because then that produces its own inefficiencies. I guess point number one, the video, these losses, yes, they do occur. Some of these losses are inevitable, and switching to renewables doesn't address the primary point of people who said that we are going to be, doesn't negate the objections of the people who say we're going to be a fossil fuel burning civilization for about the next 80 to 100 years. It doesn't also address the fact that trying to store the excess energy through battery inefficiencies and others also produce their own other types of inefficiencies when you utilize more renewable forms of technology, renewable forms of energy. Wind and solar have their own built-in inefficiencies, which weren't adequately addressed in this video. So I'm not saying that the transition shouldn't happen or will happen. It will, but the danger is that if we push too far too fast, we will collapse our energy grid, and we all will be using a far less energy, not due to efficiencies, but due to energy rationing and being cut off from the grid because there's not enough electricity to go around. And that's a forecast I've made for a while, and we should all be aware of and frightened of.
Carrie?
Yeah, I was just going to say, in terms of transitioning, I think the devil is going to be in the details. And one of the more difficult, I mean, there's some areas that are more appropriate for electrification and some that aren't. Like shipping is going to be a real tough one. I mean, at that point, I mean, what you better off just, putting sails on ships and going back to the old way of doing things. I mean, there was a reason why that worked. Putting enough batteries on a tanker to get it across the ocean is just going to be a real drag. I don't think that's going to work. And I mean, look at trains these days, right? I mean, that's probably the most efficient way to move cargo pound for pound that we've come up with yet. And I mean, they're still running on diesel, even the hybrid ones. There's a big diesel engine running the generator that then runs the electric motors that turn the wheels, which is, kind of a little encapsulation of how things work best. So I think if you're going to have a system where you are going to allow for a certain amount of fossil fuel usage, transportation sector is the one that's going to be the priority there.
Hey, David.
It's all very well and Sankey diagrams are really good at showing some of the heat lost, but they don't treat renewable energy the same way they treat fossil fuels. With fossil fuels, it's easy to see what the primary amount is. When they talk about renewables, if you really looked at the wind, there's a 40%, 50% loss between the wind and the blades on the turbine before you even start counting with the Sankey diagram how inefficient the wind generator really is. If you look at photovoltaic, it's even worse. Our photovoltaics 20 years ago were 15% efficient, which means that the sun actually produces 85% more heat than that panel converts into electricity. Now we've got multiple junction photovoltaics that use up to 40% of the energy that's in the light and heat that comes from the sun to the panel. But that 60% that goes to heat at the panel isn't even counted in the primary energy on a Sankey diagram. So it also helps to look at the cost to generate those power at each stage on the diagram. And there was a little bit of discussion early on about useful energy that the Sankey diagram counts to do things that we don't really need to do, like leaving the lights on in the basement when we're not there. That's a whole different question.
David, is that a legitimate criticism? Because I think they're assuming that the source of energy for solar and wind is infinite, and so the amount of inefficiency doesn't matter.
But it really does matter.
Well, I think the point is we're going to get the solar.
Doesn't show it.
There's
the
one
point is
critical.
we get the solar energy anyway. It's not like we're wasting something. It's not like we're mining it.
No,
and it's not like a
that's
fossil
true.
fuel. We get it anyway. So
Yeah.
It's a manufacturing cost.
May I point out that the difference between the two waste cycles is that one waste inefficiency produces excess carbon monoxide or carbon dioxide, and the other inefficiency with solar and wind does not produce excess carbon in the atmosphere.
Yeah.
yeah, and methane is an even bigger one than CO2.
I mean, that's really what we're talking about here is the greenhouse effect.
Okay, H-Tom.
Sailboats are interesting. They're actually thermal machines that are driven by the wind, which is driven by the sun. one of the hot new things in the last decade about sailboat design has been trying to arrange for a maximum amount of deck space that can be used for photovoltaic cells to recharge the batteries rather than running the diesel engine to recharge them, or to actually drive propellers. And this actually can work fairly well. Reducing this, and then people say, well, why do I need the sails? The sails are actually shadowing the solar cells, so I never put them up anymore. Yeah, missing the romance of the thing, I suppose. But this is all very good for something that you can tow behind your giant truck. But when it comes to putting something on the ocean to carry 50,000 shipping containers, solar doesn't make it. If you covered the shipping containers with solar cells and wired them up as you loaded them on, most of them are going to be in the dark. So the real solution is not to use diesel fuel, but to have nuclear powered shippers. There are more problems with this than I'm going to even attempt to list. For one thing, lots of ports wouldn't allow you in because they don't allow nuclear powered vessels of any kind. Anyway, next.
Probably seen graphs like.
Yeah. Oh, sorry, David. I didn't see you there. Oops, what happened?
David, go ahead.
One of the things about transportation and efficiency, railroads are very efficient, but actually it's cheaper to ship things by boat.
Yeah.
Um,
If there's a waterway to do it on.
right, exactly. And that's why we built a lot of canals in the United States in the 1800 to 1900 period, because we could use the rivers and then the canals to get our boats all the places we wouldn't be able to go just on the rivers.
And they were towed by horses along the canal shore.
Well, and half of the trip, the currents were working for you. I mean, a lot of barges didn't need to be powered at all if you were going in the right direction. And I mean, look at the St. Lawrence Seaway and things like that. Anyway, the other thing that the chart doesn't really show, and it would be interesting to see how much this would change, is when you include the manufacturing into the source of energy, right? And I think, at some level, if you think of the energy it takes to build like a coal-fired power plant, yeah, it's a lot of energy, but in the grand scheme of how much energy the thing produces, it's probably pretty inconsequential, as opposed to photovoltaics, where that's where your inefficiency is. It's in producing the thing on a per panel basis, and that you can amortize in, which I'm not necessarily seeing on the chart. I'm not sure if it's in there or not. The other thing, I don't know if anybody else noticed this, but that earliest diagram from the 50s, are we getting less efficient? It looked like the waste heat block was roughly the same size as the block of the useful energy. And it seemed like over time, the waste energy has been getting worse and worse.
Part of it is we're better at measuring the waste heat.
Okay. I was like, that seems really strange to me. That shouldn't be right. But yeah, that's, I guess a good explanation.
Yeah, I have a question that partially relates to that for nuclear. I mean, the mining of uranium and so forth for nuclear, I don't know if that's accounted for in the nuclear power line. The other thing that always bothered me about nuclear generating electricity from nuclear power is there's so much waste heat. I mean, it's almost 100%. You're producing heat of 100,000, a million degrees Fahrenheit to boil water, to drive a turbine. That just seems silly to me. Once you have it going, it's efficient as far as running for a long time. But the lifetime of a nuclear power plant is what, 30, 40 years until it gets too radioactive. And they're very expensive to build too. A lot of materials have to go into them. So I think nuclear, at least at this stage of technology, is not a solution for this right now, because I didn't get a good look at that chart as far as the nuclear line, but it's got to be a lot of unused or wasted energy in that line. So there's a place for it, I think, but the technology right now and the inputs required to produce it, I think, make it hard to justify at this point. So go ahead, David.
And the other thing about nuclear is, while we say there's very little waste from nuclear in terms of efficiency, we're only using the top easiest 5% of the energy that's tied up in those radioactive materials. Even nuclear could be very much more efficient.
Okay, Jason.
David's right. We don't recycle nuclear waste the way France and other countries do. Reprocess the waste materials to generate further electricity. But we are stuck. There's the broader question here with all of this is we have to ask ourselves whether through technological constraint for the time being or math and physics based realities that we can't escape from, we will for this foreseeable future, most likely until we perfect cold fusion, be restrained in large part to fossil based fuel for a number of practical reasons for the foreseeable future that will continue to make up the lion's share. So the question I have to ask is, although it is useful and useful within the context of the overall conversation on our energy makeup, is this, from a regulator standpoint, going to be used as a weapon to further regulate or impinge upon our current fossil fuel-based regime and further degrade or economically penalize their ability to deliver the services we so vitally, desperately need as a society to keep the economic and life support systems running? Is this going to be, are these inefficiencies going to be further used to throw up more regulatory roadblocks, or are we going to use this actively?
Okay.
Breaking up, Jason.
Go ahead, Kerry.
All right. I was just going to say real quick, I think with nuclear powered shipping, unless there's a real transformation in the ability to, mass produce very small nuclear reactors. I mean, the only ships right now that are powered by nuclear are military submarines, aircraft carriers, and a couple of Russian icebreakers or something like that. I mean, there's not that much out there. The other problem you get into is if you start to build a lot more nuclear power plants, you need to increase your production of, uranium or whatever you're fueling these things with. And now you're running into problems with scarcity. There's not a whole lot of this stuff. Now if there's alternative forms of powering, nuclear power plants that aren't being utilized, that's certainly an option. I've heard a lot of good ideas. I don't see them being scaled up yet, though.
Yeah, thorium's probably better than uranium, for example. Tom.
Yeah, some of the batteries or nuclear power plants or whatever that we're using in long-standing spacecraft are better in some ways than some of the things we do on the surface of the planet itself. But their cost is so high that they're not even considered in these comparisons. They're just way out of line. It would be nice to put a 500 watt little electric engine in my Subaru. But even today, this would weigh 5,000 pounds and it would go flat on the pavement like a little dead bug. So it doesn't work. Maybe someday, but not now.
Hey, Carol.
I don't know how many of you remember my presentation from a couple of years ago about solar power from outer space, because all of the problems with solar power could be solved with mirrors in the right places.
Mm-hmm.
Like the fact that the sun is always shining in outer space. You don't have that awkward period where you can't generate solar power. And we right now have the technical capability of using this solution to make it economical, because there is a hell of a buy-in cost, is a different story. But I think the long-term future of solar power generation is from satellites, either in LEO or, and I think geosynchronous would be too far out. But that's where it's going.
Okay. I like these charts they've been showing as far as the production and usage and waste of energy. But a lot of people don't think in those terms. They think in economic terms. And when they do that, however, they ignore something that's very important. And that's the, you might say, the economic fallout from global warming. When fossil fuel production and burning and transmission also is adding the methane and the CO2 to the atmosphere, it affects our climate, which increases the incidence of severe storms and drought and floods. And those had huge economic effects, trillions of dollars just in the US. And that's going to get worse over time worldwide. So that should be an impetus to try to make the switch sooner, because the effects of not only destruction of property and so forth, but displacement of human beings is going to get worse. And if we don't do something about that a lot faster than 80 years from now, the cost is going to be more than a lot of our societies can bear. So I think that's a factor that really hasn't been adequately factored in at this point. The economic fallout of the use of fossil fuels. Stan, you're next.
I'm responding to what Jason was saying earlier. I would say that if you wanted to just look at the economics of what fossil fuel has done for civilization, I mean, if you think about the time before the Industrial Revolution, you essentially had monarchies, and the class system was such that there were a lot of slaves. And so what we've been seeing since the Industrial Revolution is a migration from slavery into industry using coal and oil and fossil fuel as the slave to reduce the amount of toil and the suffering of the humanity. And that has been a great recipe for the middle class. And if you want to keep on doing that same recipe, that same plan, and if there weren't any downside, I would say that's with nothing that we talk about regarding the environment and climate change matters. But I think that the idea that there isn't a downside to climate change, or a downside to fossil fuels, is pretty much not a no-brainer. And I think that if you want to go to a fear-mongering side of the thing, if the ice shelves do collapse and there's a dramatic rise in sea level, we're going to have some terrible migration issues. I know that the military itself considers climate change as a national security issue, that there's going to be just huge amounts of people needing to move if there's more elevation to sea levels and so forth. And also just the climate itself, with the amount of desertification of lands, of tillable land, making it difficult for people to produce enough food for them to stay and to live there. That's going to be another need for transferring and migration, which is going to cause a lot of issues as well. So, I mean, there are costs of doing and costs of not doing in regards to how we navigate through this transition towards sustainable.
I'm glad you brought that up, because the way they do that is through in terms of horsepower. 1 horsepower being the equivalent of 1 live animal horse. And they said that the average human needs at least 5.5 horsepower in their private lives to maintain some base level standard of living. I would say that even the most severe climate models don't predict that the ice caps are going to melt anytime in the near future, even the next century, even by the most liberal estimates. But desertification is a far more serious threat. I don't negate that a lot of the other threats that you mentioned. I don't question them. But in terms of, if you think of things on a long enough time scale, what I'm saying is that likely before we have the technology available to utilize or transition primarily from a fossil fuel-based energy grid system to a fully renewable one, burgeoning technologies like cold fusion and other things on the horizon are likely to come into play before we fully make that transition. And so I don't think this is an either or proposition. I think that on a long enough time scale, given a century or so, about a couple, that, and we won't live to see it, mind you, but if you think of it on a long enough time scale, we don't have to choose between national security, environmental degradation, or turning off our air conditioners and shutting down the economy. I think that there's a balance that we must vitally be struck between all of these bad propositions here. There's a path forward, a middle ground, what have you, that says, oh, well, we can either have a functional economy and not let people starve to death and die, and we can not, and we could, maintain the ecosystem and not, there will be some consequence to the environment. But again, given a long enough time scale, the Earth has its ability to right itself and undo a tremendous amount of damage once we finally make it to that cleaner, brighter energy future on the other side of this. This too shall pass. If you look at human civilization in aggregate, we have overcome far greater challenges in the past. And I don't say we need to go back into the primitive dark ages prematurely out of fear and the prematureness, because we can't imagine any other way forward, and that's just what I have to say about that.
Hey, Carol.
There is one short-term effect that nobody is looking at, and that is the destruction of what these days they're calling the AMOCs. Used to be called the Gulf Stream, but the ocean currents that currently make all of Northern Europe habitable can be destroyed. And it can be destroyed by sufficient diluting of the ocean. Yeah, this would literally happen within the next 40 years. You destroy the Gulf Stream, Northern Europe becomes uninhabitable, and you have the interesting fact of economic refugees coming not from the third world, but from first world.
Okay, I guess I'm next. Yes, the Earth has a remarkable ability to recover from both global warming and global cooling. It's done that in the past a number of times, but it's over the scale of thousands of years. And I don't think we really have that much time to try to recover from what's happening now.
The Earth has also given us glaciers down as far as northern Minnesota.
Yeah, all of Europe basically at one point. But what I'm saying is, waiting 80 years before we think we can actually do something worthwhile, or not being able to accomplish much in the next 80 years is is not a solution. It contributes to the problem because there are tipping points. One of them was mentioned by Carol, another is freezing, thawing of the permafrost, which will release megatons of methane into the atmosphere. Methane is a global warming gas that's about 80 times more potent than CO2. It doesn't last as long as the atmosphere, but so its effect is a little more transient, but it's a much worse global warming thing. That's just physics and chemistry.
Nobody knows where the
And
effect.
so we have to do something quicker than the next century. We have to mitigate the problem, the what's going on sooner than that, because we will be reaching tipping points, and at that point it'll take the Earth a long time to recover, and by then societies will have collapsed and so forth. So I don't think we want to destroy our current civilization by inaction. And I think that's a possibility.
I don't think
we don't act.
I don't think we want to destroy our current civilization by panicking. And a lot of what you're saying is not backed up by good data, because we don't know where points are. We're blindly guessing here. And so in absence of good data, we can just rush headlong recklessly into throwing, and we've got to weigh other factors here when it comes to human lives, human suffering. So the irresponsible thing to do is to just throw caution to the wind and say, to hell with the concept. We're just going to go all solar and wind tomorrow, and blindly turn our backs to the real suffering and consequences to our actions. We have to make math and science-based decisions here.
Exactly. I agree with that. But there's also consequences to inaction. So it's a balancing act. It's a balancing act. And we can't, I mean, back in the 70s, the scientists at Exxon knew that what they were doing produced global warming, affected the atmosphere. And their employers responded by denigrating the science. The science is pretty solid about all this, and some people don't want to believe it, but the vast majority of reputable scientists do understand the physics and chemistry behind all this. So what we need to do is, I think we need to be a little more proactive about limiting fossil fuels. And yes, just as anytime there's a change in technology, there's going to be dislocations and so forth. But if we don't do something, I think the results could be worse than temporary dislocations of jobs and that type of thing.
Well, so, it's not like we're not doing.
As I said, it's a balancing act.
Right now.
But urging inaction is not the solution.
We're already doing a lot right now on a daily basis. It's not like we're
not doing much at all, because nothing has improved as far as our energy consumption and use and change in how we use the fossil fuels.
If you look around, we're building new solar and wind production fields every single day. We are making incredible progress in terms of renewable energy, and maybe not to the speed that's to our liking, but we can't pretend like we're not doing anything at all or making progress.
I didn't say we were.
We need to be patient, and we need to realize that humans have a remarkable degree of adapting and overcoming, and this too shall pass. But we are remarkably innovative and adaptable, and our technology will catch up. But we can't push too far too fast. Otherwise, we seriously risk breaking our basic life supported economic structures that we vitally depend upon as basic human beings, not just as a country, but as a civilization. And the threats that Carol talked about with Western Europe becoming very cold are undeniable. That is a very real threat. And I'm not denying that these ocean gyres and other things exist. These are very real threats we face, but we don't know where the tipping points are. We don't know where the cutoffs are. And so they are hidden landmines. And you're right, we might step on one, but we can't magically snap our fingers and make cold fusion technology appear. Imagine if we have infinite energy sources like through through fusion technology. Imagine what we can do with that remarkably cheap and abundant energy in excess with far less economic costs than we pay today. That will afford us a large degree of being able to construct geoengineering plants and other things to accelerate the reversal of damage in the future. So I'm usually, kind of a pessimistic, but I actually am a little bit of an optimist on this. We cannot ignore math and science here, and our best minds in these industries are telling us, hey, you guys just have to be patient. It's going to happen. We just have to wait till the technology catches up. We can't force the technology past its breaking point. Otherwise, we will break systems that we will seriously regret later on down the road. And I see the implications of that, even if they're hidden and not apparently obvious to all of you.
Yeah, it'd be
Jason,
nice if we
Jason,
had
where are you getting your data about cold fusion? I thought that was a
yeah.
proven
At
non-existent.
this point, it doesn't work.
At this point,
It'd be nice if we had a Dyson sphere too. It'd be nice, but we can't count on innovations in technology. I mean, that's nice wishful thinking, but it may or may not happen. Well, there are actions we can take now that we're not taking, is what I'm saying.
Sir, in the National Ignition Facility, we're working on fusion technology, and we're using AI algorithms to further speed up the physics problems of that. I refer to it as cold fusion, but it's just basically fusion reactors that we're working on. We've had presentations here on that in the past. We're getting closer, a lot closer, so much so that
Jason,
all right, I'll shut up.
Okay, Carol, you're next.
Okay, there's a quip going around that fusion energy has been, and I'm talking about hot fusion, the kind you get with the tokamak, has been 20 years away for the last 60 years. You can't count on the technological breakthrough when you have things that can be used that do not demand a technical breakthrough. Mirrors, outer space, beam down all the electricity you need.
There are engineering problems with that, but maybe they can be overcome.
What?
There are engineering problems with that, but they can probably be overcome.
No, the engineering problems have been overcome. It's only a question of
Time and money.
economics for the sunk cost of putting all those. You're probably going to use, the mylar stuff that they use for solar sales. We could do it today.
Okay,
No
David.
technical breakthroughs required.
But it's a huge engineering project.
Wouldn't the
Huh?
carbon costs of launch
Oh,
wouldn't the
What?
carbon costs of launching the infrastructure into space outweigh any
That's a
material?
factor. I don't know.
No,
Go ahead, David.
We don't even have to go that far, Carol. The thing about photovoltaics is that they can be done one little piece at a time. It's not a huge engineering project. They're individual economic decisions. We have the technology currently. The question is, are we going to try and develop this transition in an all of the above fashion, or are we going to concentrate on the ones that we know are cheap and easy and work? Solar and wind basically are relatively cheap, relatively easy, they work relatively well, and they can be done in very small pieces as necessary. The expectation at Rethink X, as I talked about last week, is that over the next 10 years, solar is going to become the cheapest form of energy that we've seen, and we know that it's safe. The unexpected consequences are not likely to fry New York City, for example, or flood New York City, for example.
Okay, Carrie.
Yeah, I think ultimately market forces are going to be driving this stuff, as it becomes more and more expensive to extract fossil fuels and the infrastructure increases to produce things like photovoltaics. It's just going to become an economic reality, and then boom, there's adoption, and wherever we're at in terms of the environmental situation is going to be where we're at. It's really hard to push a market without doing major interventions that tend to piss a lot of people off and whatnot. And then you have the problems of how you encourage other countries to do things and get everybody in lockstep, because you're giving certain countries a big advantage if they just say, screw it, we're going to keep doing it the old fashioned way. And now you've freed up all this supply. Fantastic, right? So that you've got that whole issue. The thing I've heard about, space-based electrical transmission, which is wonderful in theory, from my understanding. But I understand that the energy is actually beamed to Earth via microwaves. It would make a hell of a weapon, right?
mm-hmm.
I wonder if there's not an element there where people, there might be kind of a handshake deal not to implement that just for that reason. I mean, there's a, potential for accidents as well, but I don't know. I'm curious. I haven't heard much talk about it, and it seems like it should be part of the discussion, and I'm wondering why it's not.
Any new technology can have negatives as well as positives. Yeah. Doug.
Yeah, I want to follow up on David's comments. The answer to this whole problem comes up every morning. They say it's called the sun. And just a thing that happened personally to me this past week, I was with Dakota County. We had a ribbon cutting ceremony at at one site, but they put up 4 different solar arrays, one in the northern part of the county, one in Apple Valley where I live, and then a couple others. And Dakota County now is producing twice as much energy as they use within their system. And they're really kind of out there leading. No other county in the United States has been able to do that at this point. So some of that technology, especially with solar, is very, very close to home.
I've seen a lot of videos from this producer called Engineering with Rosie. and she has a very bright report about Australia's navigation through sustainable. And there's a lot of other countries like Portugal have had a great deal of success with their programs, and all these countries have different mixes of recipes of different kinds of things. Norway, of course, has got it made because of their hydropower. But there are a lot of countries that are very oriented towards getting this thing done, and they seem to be able to achieve those goals by basically using very good strategies, very brilliant strategies. And I think you're right, the market can be a force. But part of what I'm trying to do with today's discussion is to also point at inefficiency and how it can be improved.
Okay, David.
Our Tiki asked, why is the electric cost to the homeowner rising? And that's typically the case when an existing monopoly has to compete with new technology. The existing power plants have to maintain the old technology in the face of cheaper competition. As solar becomes a larger part of the production and wind becomes a larger part of the production, their cost per kilowatt hour is less than the fossil fuel plants, and particularly the old coal plants, which only may run 10 or 20% of the time and cool down in between the time they're needed to fill that last little bit of capacity. So the existing stranded assets, if you will, are going to always be facing the problem that their costs are higher than the new technology. I don't see much of any way around that unless they are investing in the new technology also, which is something I'm sure they want to be doing.
Norway was just mentioned a couple minutes ago, and yes, they have a lot of hydropower. That's what they technically or relied on for a long time, but now they have a lot of oil also from the North Sea. And so they're net exporters of energy, and that's enriched that country. But they're trying to structure it so that they don't rely on the income from the North Sea oil, and make use of solar as well as hydro. So they're taking a balanced approach, and I think that's kind of what we need. We need to get reduce our reliance on fossil fuels more, but it's as Jason says, you can't do it immediately because there'll be a lot of dislocations. On the other hand, if we wait, there's going to be a lot of dislocations because of the climate change. So as I said before, it's a balancing act, and Norway seems to be doing pretty well in navigating that kind of balancing act. H-Tom.
Yeah, when you have to go and start up a coal-fired power plant, it's expensive. It's not just, well, I suppose it is, strictly speaking, just turning a switch. But that starts shoveling the coal into the fire plant, and it starts it on fire, and then you got to heat the boiler, and then maybe you got to give the turbine a kick to get it moving because the steam pressure is too low. It becomes a very expensive process to provide that 1/10 of 1% that the grid needs. and there isn't anything we can do about it. I mean, you can take the generator out, just not have it anymore, and then we start, whose power do we shut off? Because we don't have it. I mean, we have this already. My air conditioner cycles in the summer. It's on 20 minutes an hour, 15, 30 minutes an hour. It depends. And we're going to see more and more of this. And while my house can easily handle this temperature swing, other things can't handle such power swings. Hospitals come to mind. Hospitals' air conditioning perhaps can take it, but do you want your ventilator being off 20 minutes an hour? I don't think so. And it's as we have become a more technologically based society, we are discovering there are consequences to these technologies and consequences to the consequences to the consequences to the antecedents. And it's a huge maze, and we don't understand it. And we can go in and try and patch it up and make it work better, but it's exceedingly tricky. And yes, the Humboldt current and stuff, yeah, Europe has frozen before, it will freeze again. North America has frozen before and it will freeze again. We can't control this. This time we can see it coming. And if we take good records, in 100 generations, people will be able to say, oh, that's starting again. Maybe this time we can stop it. But right now, all we can do is observe. Thank you.
Stan, I think you still have quite a few videos on your list.
I've got the times on here. I've got the next one I've got scheduled, which I'm going to probably put off, is 9 minutes. I've got a 3-minute, a 6-minute, and a 2-minute. So we can pick any of those you want to do.
Yeah, but if we have a 10 to 15-minute discussion after each one, we'll only get through a couple because we have
You've only
half
got
an hour
one
left.
more.
So I'm wondering what do you
hand
want to do?
up. You've only got one more hand up.
Well, there's two actually, but Stan, what do you want to do at this point?
Stan, if you could pick the one that you think is most worthy of discussion.
Yeah, I think there's a 6-minute one or a 7-minute one. I can pull that one up.
Okay, well, we have two hands up. Let's I guess only
I'll
one
keep it.
now. So let's take that, try to keep it brief, and then we can move on to the next video. So go ahead, Jason.
Very briefly, the answer is right here, staring us in the face the entire time. The thing that's common across most of the countries on the planet currently, outside of their political systems, is they're all at this point primarily capitalist-based societies. We in the United States are a capitalist society. Why? Because market forces are the most efficient system that our civilization has ever discovered to root out the most efficient forms of balancing production versus trade-offs and costs and whatnot. We are a market-based system, and it is the most efficient system to point the path forward. The difference is that in times past, our market-based capitalist system created the problem from which we are now trying to dig our way out from. And in centuries past, generations past, capitalism created the problem we now face, but now we have turned capitalism and market-based forces against the very problem it created, and now it is doing the most efficient job possible to actually reverse the very problem it created. And so the path forward is to listen to the markets and what they're telling us, and that will be the compass needle to point our way forward as to how we now and in the future navigate our way through the energy matrices as technology becomes available, as new resources are discovered and whatnot. We have to trust the system that has worked so well for us, and has really, we don't have anything better to replace it with. We have to put our faith in capitalism. It got us into this, and it's going to get us out of it. Thank you.
Hey, Stan.
I'm ready to go. Okay, here we go.
Okay, anything on that, Stan, before we take questions?
It pretty much speaks for itself. I thought of all the videos I've got, that was the one that kind of, the idea of stranded assets. I think that sort of indicates that there's a stronger future for new renewables. In terms of transmission, keep in mind that we're probably looking at high voltage DC as a solution. I see that as being the strongest connector for the thing about renewables is it's not so geolocated. It's available everywhere pretty much, and so just being able to create the connections between the suppliers and the need and the users, I think that we can do that. That technology exists. Go ahead, Jason.
I actually agree with primarily that was stated in this video. I found this video to be incredibly intelligent and objective and well thought, and not just because the video backed up in multiple points on multiple fronts everything I've stated thus far, that we are making incredible progress in terms of renewables, that market forces point the way, and in economics-based realities need to be taken into consideration, and that we can't just blindly make emotional-based decisions when it comes to our path forward, that we have to really take emotions out of this and look at things objectively and rationally and take a more fair, balanced, and measured approach to how we move forward. I really thought that this video sets itself apart from the standard rhetoric you see in the sphere by really being thoughtful, fair, and balanced. And so my two thumbs up. My hats are off to the makers of this video.
Thank you. And the finders.
Okay, I actually took at least one issue with the video, and that is a fundamental misrepresentation of what peak oil is all about. It's got nothing to do with running out at all. The whole significance of the peak is that every barrel of oil you extract after that is more expensive than the one prior, which changes the entire dynamic. Everything is about energy return on energy investment, right? And that's the calculation there. And just as an interesting alternative take, there was a PhD, I forget what it's in, but a guy named Richard Duncan, who came up with this thing called Olduvai theory. And I mean, really, it's more of a hypothesis or a different way of kind of figuring things. And he did some calculations based on BTUs per capita, saying that that is kind of ultimately what our standard of living could be, right? You know, now obviously it's not distributed evenly, and that's an issue of equity or whatnot. But according to his calculations, I want to say that we passed peak energy per person in like the late 70s or early 80s, which has some interesting implications if you think about it that way. Now, I do agree with the video that, you know, the market is always changing, and as new things come online, it absolutely changes the dynamics. But anyway, I just wanted to throw that out there. Thanks.
Yeah, efficiencies have a big factor too, and that's improved. Any other questions?
But at least they put it in the annex.
Tom, go ahead. What'd you say?
But at least they put it in the annex, even if it was on page 47.
Yeah, I think this is one of the things about the miscommunication and the confusion, and also the obfuscation, I think it's a word I'm trying to learn how to use more, that I think that the petroleum companies are using to try to sort of distort things, putting their hand on the scale kind of thing. Bottom line is that it's very difficult to choose your. I mean, if you're a golfer, you have to sit there and go, which club am I going to use? I guess so they say, it's, you know, facts don't lie, but liars use figures and so sort of thing.
Okay,
Go ahead.
Jason.
I think the saying is facts don't care about your feelings. But and it's true, facts don't care about your feelings because feelings don't alter facts, which is why you shouldn't make your decisions based on feelings. Listen, I got listening to this talk, I want to introduce an insanely scary, downright spooky notion here. And that's the sun travels in 12-year cycles, solar cycles. We are currently in the solar maximum period of our sun's solar cycle, which means that right now we are experiencing more coronal mass ejections, CMEs, than at other times during the solar cycle, which happens to some degree all the time. So the Earth is really in a shooting gallery in outer space, and that the last time it hit us directly in just the right precise way, it was called the Carrington event. Now, it occurred to me during all of this discussion that if such an event were to happen today, it would be monumentally catastrophic. But more so if we had fully transitioned to a renewable-based energy. And so it occurs to me that it would be a lot easier to get a coal or a fossil fuel-based energy provider back online than a wind or solar. So if we are going to transition anyway, which we're currently doing, we should take the time and added expense to build in the safeguards to not only provide a degree of protection from coronal mass ejections, solar flares, but also electromagnetic pulses, which our enemies are currently have and can deploy against us to shut down our entire energy and communication networks. The military already hardens their communication and weapons-based technology against electromagnetic pulses. This would not be cheap. But during a Senate subcommittee hearing, which Newt Gingrich was the head of, based on intelligence, our own intelligence agencies like the CIA and others, from data they collected, if we were attacked by an EMP or hit by a coronal mass ejection today, they estimated, based on their figures, based on the best available data, that 98% of the country would be dead within a matter of months. That's 98 out of every 100 people. Only 2% of the total population would survive. So imagine a bright and utopian future where fossil fuels are a thing of the past. And then here comes along a coronal mass ejection one day out of the blue, maybe not even during the solar maximum. And we're caught with our pants down, and it takes down the entire grid. Now 98% of the population of our entire country dies within 2 months or less because we've got no way to transport food and logistics. Communication is down. Basic sanitation, emergency systems are down. Our energy systems are down. We freeze, we starve, we overheat. You get the picture. If you want to see this, there's books called 1 Second After and another novel called Lights Out. And it was written based on expert feedback in these sectors. So that's something we ought to think about when we rebuild the grid to be more sustainable and based on renewable energy. We need to put in safeguards, cutoffs for coronal mass ejections and electromagnetic pulse weapons, because it's not a question of if, it's a question of when. We know on a long enough time scale, this will definitively happen again, even if we are not attacked by our enemies. Thank you.
Lionel?
Okay. Oh, Lionel, yeah. Lionel, you're muted,
Muted.
Lionel.
Lionel, you're muted.
One of the things I didn't see factored in here is there's a cost to build stuff in terms of energy used and materials used, and then there's costs to extract materials and indirect costs and all of those things. It's like there's this funnel of hidden costs, and they weren't in the equations in any way that I could see. Anybody have any thoughts on that?
Yeah, I wasn't sure if that was included in the energy part of that chart, the first of the 4 sectors or not.
Oh, okay. Yeah. Anyway, it was just it's definitely something that has to be in there or the curves are going to be off.
Yeah.
My
David,
opinion, anyway. That was it.
Sounds like a possible topic for a future discussion, given the time.
Mhm.
oh, yeah, it is afternoon.
Did you want to finish up with something, Stan? And I'd like to say something about next week.
Actually, I'm very pleased that my goal for today was to try to extract as much interesting ideas and conversation as possible, and I think I met my goal. So my theme was to try to come to grips with some of the ways that energy usage is presented and how it can possibly be, we can examine some of the, and using efficiency as being one way to sort of prioritize our schedule for what could be done about the transition. And if fossil fuels are a greatest part of that unused or the waste energy, that would be a good place to start with the transition.
Okay. Well, I guess that concludes the presentation. Oh, we do have a few more hands up. So I think Carol is next.
Yeah, I would like to mention that I did a presentation a couple of years ago, maybe a year ago, on the possible effects of another Carrington event. So that's out there if you've got a record of it. And also, obligatory SF reference, a book called To Be Taught If Unfortunate by Becky Chambers. This is in chat, which discusses a future Carrington event destroying civilization.
Yeah, I think I mentioned that in my talk year and a half ago about doomsday scenarios too. That was
Yep.
part of one of them. Chris, go ahead.
I thought that Jason's argument was pretty solid in saying we should have some residual fossil fuel capacity. Are there any flaws to his argument that anybody can bring up? I thought it was pretty solid.
I think generally it's a good idea to have alternatives. We shouldn't be reliant on just one thing. Um, Solar is pretty reliable, but I mean, we can have things like Carrington events or um, long-term darkness, clouds or whatever. I don't know. Um, but fossil fuels, I think, are not the best answer. Right now, that is our answer. But I think the more we can move off of them and maybe go to nuclear as an alternative or whatever, the better. Nuclear is a problem because it takes a long time to get it online. But
It sounds like you do not have a argument against Jason's statement.
well, the only thing I object to about what Jason's saying is that we have a long time horizon to change the way we operate our energy system. I don't think we have that long a horizon as he thinks. So, Carrie, go ahead.
Yeah, as far as, resiliency, I mean, my understanding is in terms of hardening the grid, it's basically having replacement parts. The big transformers and what's stockpiled and ready to go, which is a huge expense, but it's not completely, out of the question. My understanding is a lot of military systems where you can't shield the thing. They just have a spare unit. You pull out one box, swap in the other one after a nuke goes off, and then you're back up and running. So you're kind of looking at redundancy. But the other angle on this is personal redundancy, and in disaster preparedness, having a deep larder is not a bad way to go. And there's no reason why most of us can't stockpile an extra few months of food, if you really needed to. I mean, hey, you're buying it at cheaper prices and whatnot, Store what you buy what you store, have a little bit extra. And, if there's ever a disruption, you'll be glad you had it.
Doug.
Yeah, just to back up what Kerry said, MRES is in the process of putting up a 500 kW system for the city of Minneapolis. What's holding us up is the transformer from Excel, which has a 52-week lead time. So some of that stuff is way out there. So thanks.
Yeah, I think that's why we need more decentralized energy production. So personal, like solar cells I have on my roof, that type of thing. Go ahead, Tom. You're muted, Tom.
Decentralized production is a good thing, but building giant transformers is a tricky business. This is something my brother does. The complaints he has about supply chains and improper storage of materials both before and after assembly left to raise hairs in the back of your neck. Storage of things to protect them from a Carrington event is a tricky proposition. There are unknown but projected nasty things that can happen that will defeat much, but not all, possible ways of shielding. If we're going to talk about horrible, something that actually gave me nightmares for a couple nights, Annie Jacobson's Nuclear War should probably be read by everybody on the planet. It's a very realistic look at how we don't need a Carrington event. We can make our own. And having been not on the point of that spear, but on one of the lashings holding a spearhead to the spear, it's too real to be ignored.
Tom is correct basically when he states these residual transformers and spare parts need to be stored in what basically amounts to a solid Faraday cage. And we do know how to construct those. There are many videos.
Yeah,
you
but making them big enough for a half megawatt power transformer is a different proposition than a metal box.
How much do we currently spend on national defense each year? What's our national defense budget? We talk about the implications of this magnitude. We're talking about losing the population of the United States.
Yeah.
So one could say that through incentives and economic policies, we could make it more of a priority. And if we don't, we might be sealing our own doom.
Mm-hmm.
I thought you were very much against incentives and policies and that kind of thing.
Well, regulation, I don't demonize like anything. There has to be a middle ground. You know, you take into either extreme, anything can be too much of a good thing can be bad. There is a place for regulation. There is a place for economic stimulus. There is a place for subsidies, but you have to. You can't go to either extreme. They have to find a happy medium. So, yeah, I believe very much in common sense approaches to things. And
okay. We're at 10 after, so let's try to finish this up. We have still two hands, Carrie and then Doug.
Okay, yeah, real quick. I would just, put the stockpiling of large transformers in the same category as a strategic reserve, right? We have a strategic petroleum reserve. Why not have the same thing for transformers?
We have that.
Which? The transformers?
Yeah.
Where is it?
That would be telling.
Don't.
We have a strategic reserve of them, and we are constantly taking them and putting them into service and replacing them with others. When you come along with a new demand, you can't draw it from the reserve. The reserve is used for those that fail.
That's a just-in-time operational reserve, just in time.
Right.
Yeah, and my understanding is a lot of these things come from China ultimately, which is a problem too. And I mean, correct me if I'm wrong, but I mean, couldn't you put these things, what's wrong with putting them in a big metal box or underground?
Indonesia makes a lot of them too.
Okay.
Doug,
You're right.
Doug, you're next.
Yeah, I just want to thank Stan for this presentation. I think it's been really good, really, really a great way to look at things. And the other thing I just wanted to share, that, living without electricity is possible. I spent 13 years growing up without it, and, it was a good life. So you can live without it. I do know that. But thanks again, Stan.
Not
living without electricity in a nice environment is really cool as well.
the simple breakdown of
David,
society.
you're next.
you.
Yeah, I just wanted to suggest that we don't have a single presenter for next week. So we're talking about a medley or a potpourri. We'll have, I hope, 3 or 4 separate short presentations. If you would like to know what's coming up, I would hope that the people who are planning to bring something will send me something and I can post it.
Will do.
David, I've got a file that I'm keeping a lot of videos that I've been watching. I'm going to send that to you. I'm going to take my trip to Des Moines to see my brother next weekend, so I won't be here, but I will be sending you those videos.
Thank you. Also, it's a nice heads up that we need somebody else to record the meeting.
Yeah, that's true.
David, can I share something?
Sure.
Just for our interest, I've been putting together speakers for about 15 years for MRES. And in the month of November, I have what I think is going to be a really, really good one. The people from ASUS, the American Solar Energy Society, got a huge grant to work with Pine Ridge Reservation and put up solar out there. And so that within itself is a pretty amazing story, because Pine Ridge is like the lowest income place in the country, I think. But what else is going on there is what I think is so wonderful is they've come up with a new way of building houses, and they have building like dome homes with a material that can withstand the heat and cold of that area. And so anyway, if people would like to see that, we do it on the 3rd Thursday of every month at 6 p.m. So you can just go to the MRES website and just connect. There'll be a write-up on who's presenting and everything. And then there'll be just connect with it there, and it goes for about an hour. That's on the 21st of November. Just heads up on that one.
Is that posted to YouTube then later?
Yeah, it will be turned into a YouTube later, and I've got about, I think, 120 YouTube talks up on our site. So some very interesting talks over the years, from hydrogen to nuclear to you name it, and everything in between. In fact, one of the most interesting talks, or we had the most people at, was the one on a refuge plant there at Newport. So anyway, just wanted to share that with everybody.
So what is the MRES site?
It's mnrenewables.org.
Okay. And we can access those videos from there?
Yeah, you just go to that website, and the speaker information is sitting there along with lots of other stuff from us. And then we also send out a newsletter to about 7,000 people every month, and you can get on that list as a member, or you can, catch most of it from the website too. So.
Okay, thanks, Doug. And thanks, Stan. That was, as other people said, that was a good, interesting presentation.
Thank you.
So next
Gotta go.
next week we'll get the potpourri and try to get some stuff posted as to what topics will be covered on that.
Okay.
All right.
Thanks, everybody. See you
Take
next
care.
week.
Thank you.
Bye.
All right, I'm going to shut the whole thing down here. I'm
Okay.
gonna take care.
Thank you for
Be
the
good.
presentation, Dan. I'm sorry to be such a gadfly.
No, that's you, Jason, and I expect it, and I actually kind of like it, so it's all right.
Yep.
I like to talk about Christopher Hitchens and his brother Peter Hitchens. They actually are brothers, and they debate very interesting debates. So it makes for interesting listening. All right, well, I'm gonna end this thing here. I'm getting interested in lunch. So
Bye
take care.
bye. Thanks,
Bye-bye.
Dan. Great presentation.
Thank you. Bye bye.